Alright, let's create a new project. We're going to call this project Java Objects. And inside of our project folder, we could create a new class, call it string objects. And we'll get started by creating two variables. The first one we will call num1. It will be of int type. And the next one will be of string type called name. Now, first off, we can see that when we declare these variables, the data types are different colors. Int is an orange color and string is a blue color. That's because these are two different types of data types. Int is a primitive data type and string is actually a class. If we hover over, we see we have java.lang.string. String would actually be what's called a class. And when we give the variable the name, what we're doing is actually declaring an object. Now, if you remember, Java is an object-oriented programming language, and this is what makes it an object-oriented language. Objects are used to create a form of efficiency in programming. They allow us to reuse code. That's the main purpose of using objects in any programming language. And objects are created or instantiated from classes. So you could see here that the object name came from the string class that came from a package, which specifically is the lang package, which came from the Java API, which is what the path to the string class tells us. So now that we know the difference between a primitive data type and an object, let's go ahead and create another int variable up top here. We'll call this one num2. And down here we will initialize these variables. Num1 we will initialize to 5 and num2 we will initialize to 3. Next we'll go ahead and put two print line statements to print out these variable values. And when we run this program, we can see we get the values of these variables, which is 5 and 3. Okay, now let's set our num1 variable equal to num2. And let's see what happens if we print these new values out. And as you can see, before we set num1 equal to num2, we had our variable set to 5 and 3. And after we assigned a new value to num1, you could see we get the value that was stored in num2 to begin with for both variables, which is 3. Okay, now let's create another string variable. We'll call this one name2. Notice we haven't initialized these variables yet to any value. That's why they have the yellow squiggly underneath. So we'll go ahead and do that. We will initialize the first string variable called name. We'll initialize that to Bob. Now there's a couple ways we can initialize this variable. The first way is just to set it equal to Bob in quotation marks. The next way is the proper way to declare objects, which is by using the new keyword, by setting the variable equal to the new space and then the name of the object class and then the value that you want to initialize that object to in parentheses with quotation marks. You could even do this all in one line like we have previously. So we'll go ahead and get rid of this first declaration up top and we'll just go ahead and declare both of these variables in their own lines. And just to show you that it will work both ways, for the first variable name, we'll declare it using the new keyword. And for the second variable name2, we will go ahead and declare it just by setting it equal to Alice in quotation marks. Now the Java API is what allows us to declare the string variable type the way we did it with the name2 variable by just putting it in quotation marks without using the new keyword. That won't work for all objects. It mainly works for the string class just because string is used so often. The Java API is set up so that we could declare it this way. So if we go ahead and print out these variable values, we'll get what you might expect. Which is Bob printed out and then Alice printed out underneath it. Here let's set our name object equal to our name2 object. If we print this out, you can see we get Alice, Alice. That's because the name Alice, which was stored in our name2 object, replaced the value that was stored in our name object, which was Bob. Now let's go ahead and set our name object back to Bob. and run this. And as you can see, we have our name variable back to Bob and our name2 variable still at Alice. Now there's something important to give attention to when you're looking at how the values stored in primitive data types differ from the values stored in objects. So let's go ahead and take a closer look at how the process of this occurs. Now when we created our first two int variables, num1 and num2, what we did was assigned a variable name as well as the value that we gave to that variable inside of a memory block. A specific amount of memory will be assigned to that particular variable, and inside of that block of memory, the name of the variable as well as the value that you store in that variable will be put inside of that memory block. When we set num1 equal to num2, essentially what we did is we went into that piece of memory and we actually changed the value to 3. So now that same piece of memory has the initial name num1 that we gave to a variable and a new value stored with it as well, 3. This changes when we are using objects. So for instance, with the string class, when we declared the first string variable name to Bob, the value Bob does not actually get stored in the same block of memory that the name that we gave to that variable, which in this case is name. Bob actually stores in another memory block, separate from the memory block that stores the name we gave to that variable. And instead of the block that stores the name of the variable containing the value of the variable, what it does is actually stores the address of the memory block that Bob is stored in. And the same with the name2 variable. When we declared that, what we did was we created a block of memory, and in that block of memory, we store the name of the variable, which is name2 in this case, as well as the address of the block of memory that the value Alice is stored in. If you're familiar with the C++ programming language, you know that this is something similar to how pointers work. Now when we assign the value of the name2 variable to the name variable, what we did is change the address stored in the memory block of the name variable from the address that stores the value Bob to the address that stores the value Alice. So now both of these variables, actually the blocks of memory that store the variable names, also contain the address of the allocated memory that stores the value Alice. And because both of these blocks of memory both point to the same different block of memory, name would be called an alias of the name2 variable. Now next we reassigned the name variable back to Bob. Now what do you think happens when we reassign the value back to Bob? Does Bob's address automatically just change back to the previous address of memory that was allocated to store the value Bob in it? And the answer is no, it does not. You see, when we assign the value of name2 to name, what actually happens is the initial block of memory that stored Bob gets freed up, and that block of memory no longer contains the value Bob. Now the Java programming language has what's called a garbage collector that runs periodically. So in cases like this, where a block of memory gets freed up, the garbage collector will then make that block of memory available for other resources that might need it. So what actually happens is a new block of memory gets allocated to hold the value of Bob. And then the block of memory that stores the variable name gets a new address that is stored into it. And that would be the address of the new block of memory that was allocated. So if you remember in a previous video, we used the scanner class. And in order to use the scanner class, we had to import that class. And we did so by typing at the top import java.util.scanner. Now if you notice, if we hover over the string, the path for the string class was actually java.lang.string. So as you might guess, we can import almost an endless amount of packages that contain classes that can make our programming process easier or more efficient at the least. Now with the string class, Similarly to why we said we didn't need to use the new keyword to instantiate a new string object, we do not have to import the string class up top like we do the scanner class. And once again, that's something that the Java programming language implements because of how often the string class is used. So when declaring a new scanner object, notice we must use the new keyword, unlike when we are declaring a string object. And if you remember, when we put input dot, we get a list of what are called methods or functions that are available to us through using this object type. Now, all these methods that are available to us through this object allow us to operate on this object itself. And the same is true for a string object. If we put name dot, we could see methods that are available to us through the string class. If we try some of these out, you could get an idea of how methods actually work with objects. So if we take this method here, to uppercase, notice the parentheses that come after to uppercase. Now sometimes these parentheses will contain parameters, but for this case we do not need any, so we will just go ahead and leave these parentheses empty. And in order to view what this method does to our name object, we'll have to put it in a print line statement, so we'll go ahead and do that. And when we run the program, as you can see, we have Bob, but all letters are capitalized. So that's what that method to uppercase did to our name object. We also have a method that is called to lowercase, that, as you might guess, puts all letters in lowercase. We'll go ahead and print that out here so we could see it. As you can see, there's a good amount of methods that are contained within this string class. We'll go ahead and check out another one here. This one is called equals. And what this is going to do is check what we have in the parentheses here and see if it equals the value that is stored in our name object. So we'll go ahead and put Alice in the parentheses, in the quotation marks. And obviously Alice does not equal Bob, so we get the value false. As you can see, if we hover over this and we go under returns, we could see that this method returns a value of true or false, depending on the parameter Alice that we gave it. If we put Bob in here, notice the first letter of Bob is lowercase, we are going to get false as well, and it is because of that lowercase letter. Our original name object had an uppercase B for the first letter. If we change that, you could see we can get the value true. If we wanted to allow a lowercase b, we could just change this method from equals to equals ignore case. And as long as the letters match, the cases can vary, and we could still get true if the letters all match. And the last method that we will look at is called char at. And what this method does is returns a particular character at a specific index. So let's say in our name object with the value Bob, we want to return our O character. And our O is actually index 1, with the big B being index 0, and the last B being index 2. So we'll go ahead and put 1 as a parameter in these parentheses. And as you can see, we get O printed out.